Let's talk more about chords. So one of the things that's true about chords is if one chord is a perpendicular bisector of another chord, then the first chord is a diameter. What does that mean? Well, here we have chord SQ because it's clearly on the circle. We have chord RT, which is clearly a chord, clearly on the circle. And it's perpendicular. It bisects it. So that means that SQ is the diameter of the circle. Let's go look at the other side of the rule. The other side of the rule, here we clearly have EG is a diameter, because here's the center. And there's another chord that runs through it, so therefore it is that it intercepts at a right angle, so therefore it bisects this chord. So FH is going to be congruent to HD. FH here is going to be congruent to HD because we know that EG is indeed diameter. So let's take a look at an example of how we would apply this. If we wanted to find, let's go to purple, AC equals what? Well, BD goes through the middle, so it's a diameter. It hits AC at a right angle. AF, AF equals 7, and segment AF is congruent to segment CF, so therefore AC equals 14. All right, so here we have segment BD is a diameter because it goes through the center point of circle A here. So if arc CD is 9 degrees and arc 80 is, arc DE is 80 minus X. Well, if we come back here and we know that BD cuts segment CA in half, then we also can figure that arc CB is going to be congruent to arc AB. If it cuts the chord that forms the arc and bisects it, it's also going to bisect the arcs. So let's come back to our problem and figure out what is the measure of all these arcs. Let's go back to our purple. So 9x equals 80 minus x. A little more room. Add x to both sides. 80 because that can't, 80 because that cancels. So x equals 8. We come up here 9 times 8 equals 72. And 80 minus 8 equals 72. So we've just shown that arc CD, the measure of arc CD is 72 degrees. The measure of arc ED is 72 degrees. And the measure of arc CE, right here, equals 144 degrees. What else do we know about chords and circles and things in general? So here we have a circle with two chords, AB and CD, and as we can see, they are both have right angles to the center. And we measure everything from a point to a line at a right angle, so it's the same all the time. Well, if this is a right angle through the center, this is going to form a diameter. This one here is also going to form a diameter, which means what? Which means these are going to be bisected. Why is that important? Well, we'll look at that here in a second. But if that EF is congruent to EG, then AB is congruent to CD. Because it's in a circle, circles have the same radius, it's the same distance from the center point, then the chords are going to be bisected, they're going to end up being the same. So can we use that to our advantage? We sure can. Here's an example. Here we have chord QR, chord ST, and we can see that they're both 16. We have, let's label these. We have CU and CV. And since QR is 16 and ST is 16, we can honestly say that CU is congruent with CV. So 2x is going to equal 5x minus 9. We can find out the length of CU and CV. So give myself a little bit more room here. Minus 2x here. And x equals 3. So CU equals 2x, which equals 2 times 3, or 6. And CV equals 5x minus 9, which equals 5 times 2 is 10, minus 9. 5x times 3, is 15 minus 9 equals 6. And we are done.